Okay, I'm going to spend a few minutes talking to you about light sources. We're nowhere using an LED for this project, but going back maybe 10 years or so, if I was teaching a lighting project, I'd probably have chosen to use one of these little things here. This is a called an MES, miniature Edison screw incandescent bulb. Now I don't know if you can see inside that, but there's a tiny little tungsten wire called a filament, and if you put electricity through it, it gets very hot, and it gets so hot it glows, so it gives off what we call incandescent light, and it's really inefficient. Okay, so we're talking about 40% light, 60% heat. So in terms of how it uses the battery, it's really not efficient at all. And we put a little bulb like that. So I forgot to say though, so inside that glass bulb there, all the air has been taken out, so it's a vacuum, so that tungsten doesn't burn out quite as quickly. It will burn out. They don't have a terribly long lifespan, and they're pretty inefficient. Also, if I drop that glass bulb will shatter, so I've got to be really careful with it. So that little MES batten bulb holder is kind of consigned to history now, I guess. What we do if we're using those, we'd screw it into a batten bulb holder like that, and we'd put wires to either side of it. By the way, this bulb wouldn't be fussy if you put a plus in this side or minus in this side, or reverse them over, it would still light up. As long as the current was flowing through the filament, it would glow and give us incandescent light. So there you are. Say goodbye to Mr. Incandescent light bulb. Sooner or later, just like normal light bulbs you put in your house, you won't be able to buy those anymore. Now, so why have we gone over to LEDs? Well, because something the size of this can give us a comparable amount of light, sometimes even more light than an incandescent bulb, and it's much more efficient. Okay, we're talking about sort of in over 90% efficiency, and the heat that does come off isn't from the light, it's from the power supply that gives it the power. Okay, because sometimes you have to reduce the voltage and things that goes to it, or control the current going to it, and that little device will use some of the power. Okay, so here's your LED. Right now, this one here I've already soldered onto some cables. Hidden inside here is a little thing called a resistor that reduces the current going to the LED, so it does need a little bit more in terms of using circuitry to build the system. Your bulb wouldn't have needed a resistor on there. Okay, other things with your bulb, if you wanted to reduce the current going to the bulb, or the voltage going to the bulb, that bulb would dim. If you want to dim an LED, then you've got to go down the route of writing a bit of code to make it dim, and doing what's called pulse width modulation, PWM we call it, right? Okay, so there's my LED, and let's have a look and see what other kind of LEDs are available. So I'll look at this one first, right? So this one here is another white LED like the first one I showed you, but this one is in a much smaller body. I think this one's 3mm diameter. This one is 5mm diameter, so it's a little bit smaller. Gives off a really good quality light though, bright white light, just in a smaller body basically. Oh look, one other really important thing to mention. When you look at the legs on your LED, you get a long leg and a short leg. Okay, the long leg is the plus, the short leg is the minus. So we call the plus the anode, and the minus the cathode, right? The cathode is the short one, or the minus. So when we're putting wires to LEDs, we put the black one on the short one, the red one on the long one. Well, red is always a plus in the circuits that we make. Okay, so there's a different kind of LED. Let's have a look at another LED. So this one here doesn't look like the first two at all. This is what we call a 1-watt Luxion LED. These give off an insane amount of light, really bright and powerful. You do need a protective circuit with them, or a driver circuit sometimes, and the only way you can tell cathode and anode on this one is the little circular hole that you can see by there, which denotes the fact that that's the cathode, right? So yeah, when you put those together, you'll see how much light you come from those. They are dazzling. You couldn't look directly into that when it was on. It'll blind you. Well, not quite blind you, but it's very bright. Okay, standard LEDs come in different colours, so you can have like orange, red, I've got green. You can get blue ones, but they're pretty expensive, so I don't tend to have many blue ones. For some reason they're more expensive. So there's standard 5mm LEDs. Right, this one looks like a standard 5mm LED until you look closely at it, and you can see there's a little black dot inside the side of it there, just by here. Now that black dot is actually what we call an IC, or integrated circuit. So the IC, what it'll do is when you put power into this through the anode to the cathode, it'll tell the LED to start flashing. So that's a flashing LED. So no other circuit required. Put a battery on it and that'll just flash away for you. So that's quite a cool little LED. This one here, look, So this one looks similar to the others as well, a bit sort of milky colour. This one, look, when you look inside it, the anode and the cathode, they look the same size. If you look at the standard LEDs, let me have a look at the standard LEDs. If you look inside them, you can't see through that one very well. So if I look inside the clear one, okay, you can see inside that one of the terminals is bigger than the other. This one, they're both the same size. This little LED does something really clever. Okay, it's a colour changing LED. So what you do is you plug the power into that and it'll just scroll through a different range of colours going red, green, blue, and it just does it as sort of rainbow effect as it's doing it. So that's quite a nice one. They're not cheap though, okay, we're talking about 70-80p for one of those. So that's quite expensive. I'll say let's go through even further. So here we've got an LED. Look how many legs that's got. So that's got 4 legs altogether. So this is what we call an RGB LED. RGB standing for red, green and blue. So you'd think that just needed 3 legs, but you need to have a negative leg. So this is what we call a common cathode RGB LED. So in other words, red, green and blue channels all share the same minus, the same cathode, right? So we connect that to the minus, and then depending on which one of these legs we send power to, we get either red, green or blue. But the clever thing is we can send signal down 2 of the legs with like 50% red, 30% blue, and we'll get some kind of purple coming out of here. So we can change the colour of this LED by coding to tell it send different channels, different analog signals, and our RGB LED will make any colour we choose. So he's a pretty cool LED, well worth investigating. Right, now we come down to what we call zip LEDs. So zip LEDs are these ones, I think I've talked about them before. Zip comes from zip code, like a postcode in America. So basically what it's saying is each one of these separate LEDs is addressable. So you can send a signal to this address, or this address, or this address, or all of the addresses to do certain things. So zip LEDs need 3 connections, okay? So you can ignore one of these for the time being. You get a minus, a plus, and then you get a signal wire. So this has to go to your negative on your microbit, the one that says GND, and this has to go to power. Now you do have to check whether you need extra power for these. Some of these don't work at the microbit board power, which is about 3.3 volts. Some of them went up to 5 volts, so you might need to have an extra set of batteries for these. The middle one is your signal, so you can send that to one of your output pins to make them work. But RGB LEDs, you can make them make any single colour you want. You can also control them individually. So if I had this one connected, say for example, to a temperature sensor, and I wrote a microbit program, I could make myself a visual thermometer, and the colours of these would change as the colour of the input went up or down. So that'd be quite a nice thing to do. Okay, RGB LEDs don't just have to be a straight strip. So this is exactly the same little zip LEDs, but they're configured to be in a circle. So if you put that one into your lamp design, you can run lights round in a circle. You could have a rainbow effect going round and circling around here. You could make them all make the same colour. You could do all sorts of things. So this is called a zip LED, and I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 LEDs on your matrix. And then lastly, you could come to these. Now this is an adhesive backed zip LED. You can cut these to be any size you want, so I can use them individually if I want to. There's your 3 wires. So I've got power, if you can see there. Oh, 1 second, that's GND. So that's my minus, the green one. And on the left hand side there, you can see it says 5V. So that's my power, plus power. And the middle one is my signal. So I just soldered these wires on really carefully to my board, and now I can tell it which LED I want to program and make them make different colours. So you can stick that into your designs. If you just peel the back of that label off, that's sticky backed LEDs. So yeah, brief introduction to what LEDs are and how they can work. There's more to it than that. LED lighting projects can be really complex, well worth getting into. All right.